Hi, calculus students. I had a couple of requests for some specific problems from the AP Unit 4 questions. The first one is number 4, the second one's number 12, and the third one's number 18. Here's number 4. I try to draw a picture of it as well as I could, and the question is, when does the instantaneous rate of change equal to the average rate of change over that value? Well, where does it happen? This is the mean value theorem for derivatives, where the slope of the tangent line equals the slope of the secant line here, here, and here. So for how many values does that occur? 3. Next, this one was a little tougher. I'll try to go through as quickly as I can, but I don't want to lose anybody. Number 12, we've got this conical bin, and it's got a leak in it, and it's losing whatever fluid or corn that's in there at a rate of, the volume's changing at a rate of 12 cubic feet per hour, okay? So what we do on these problems is we take inventory on the variables that we were given. The volume it's losing volume at a rate of 12. The actual volume at noon is 27 pi. Find dH dt. So that's what I like to do, take inventory of what I have and what I'm being given, given to find, that is. Notice that there's no r's. Since there's no r's, we're going to have to remove that from our equation somehow. We need to write an equation that relates dv dt to dH dt, so we need an equation with just h's and v's. So here we go to get an equation with just h's and v's, so I can substitute in that r and get it out of there. We got to get rid of r. We do it with similar triangles. This tiny little similar triangle, r is the radius, h is the height. This large triangle, 5 is the radius, 15 is the height. So I set up a proportion. We know that they're both similar. Do you guys remember this from geometry class? We've got, first of all, it's an altitude, so we're assuming both of those angles are right. And then this vertex angle is congruent to itself from the small and itself from the larger triangle. So r is to h from the small guy equals 5 is to 15. Then I multiply both sides by h. Whoop, there it goes. And then got an r value of h over 3. Everywhere you see an r, replace it with h over 3. So you're going to have to square that. Square the top, square the bottom. It turns into this. Combine some like terms, multiply these. Yep, and yep. So now we have an equation that relates v and h. So we got to take the derivative of both sides. Taking the derivative of a v, you just took a derivative of a v, tack on dv dt. Take it down, multiply it around, 3, leave the constant alone, and it decreases by 1, but you just took the derivative of an h, tack on dH dt. Now it's time to substitute all the values in there. So 12, some of that stuff dropped out, and I'm looking for dH dt, and shoot, I don't have what h is. I need to find what h is at noon at that specific time period. So here's my volume equation with just h's in it. Volume equals this. Find the missing h when the volume at noon was 27 pi. Solving for h, I got 9. So that 9 goes in here for h, and square it immediately. Now it's 81. Cancel it with those 9s, invert and multiply, and you get 4 over 3 pi feet per hour. That one was a tough one. Let's move on. The next one looks like this. Its picture looks like this. And the points in question that we really need are g of 0, because that's 3. And then we need to find the slope of this line at 0. We'll come back to that picture here in a minute. This is number 18 from the AP Unit 4 review. I hope you enjoyed doing that. It's certainly fun to see the feedback. And I think I can exclusively assign those questions from that website. And we can take a couple of quizzes and then the last test via the website. So first, we're going to try to evaluate the limit as x approaches 0. Change all your x's into zeros. So when you send a 0 to the G'ing machine, you have to figure out what the corresponding y value is at that spot, and it's 3. So that gets erased and replaced with a 3, and everything else turns into zeros. Can you see it okay? I get 0 over 0, which is the most common indeterminate form. Good news for us, we can use L'Hopital. When you get 0 over 0 taking the derivatives, use L'Hopital. Using L'Hopital on this, we have to take the derivative of the top independently from the derivative of the bottom. Well, this portion of the derivative of the top, that is what's the big picture? That's right, it's the product rule. So you're going to have to use the product rule on that part. It's the first times the derivative of the second. When you take the derivative of the inside stuff, you get that -1, plus the second times the derivative of the first. Well, you don't know what the first is. It's just g. So the derivative of g is g prime at x. Taking the derivative of the bottom, it's just a polynomial. So take it down, multiply it around. It decreases by 1. Here it is. It's time to reapply the limit. Change all your x's back into zeros. When you change that bottom one into 0, everything drops out. That's nice, and you're left with -2. We need to find the y value again at 0. So look at the equation. The y value is 3. So that got replaced with a 3. Anything to the 0 power is 1 times that -1. Bingo. I forgot to mention this. I forgot to mention, when I was taking the derivative of the top, I was just doing this, and that's the product rule. I forgot to take the derivative of -3. And the derivative of -3, it gone. That's the constant. So I forgot it, but luckily for us, we didn't need it. The derivative of that -3 is gone. Okay, let's keep going. The product rule has a plus sign in between. Anything to the 0 power is 1. Now we have to find the slope of the tangent line at 0. So when you look at it on the website, you can find the slope of this tangent line by going up 1, 2, and over 1. Rise over run, so the change in y divided by the change in x is 2 over 1. We went up, it's positive. We went right, it's positive. And that's where this 2 comes from. It's the slope of the tangent line at that spot. Once we've done that, it becomes all arithmetic here. So we just multiply, simplify. Pretty fun problem, huh? I hope that you guys enjoyed doing those problems and it wasn't too much of a hassle for you to log in. Work on all problems from the AP book that you have not done yet because they weren't assigned. And stay healthy, okay? This 4-day weekend, I only want you to work on practicing problems. If you haven't finished the Q4, the questions from the AP website, please work on those too. Talk to you soon.